Okay, here's the last example that we're going to look at today on expected value. I know it says number 4, but this is our third example. The probability of a casino game has been calculated by the following. So we have the charts here on the casino game, and we've got here winning results is when you play a game, it's possible you win nothing, which means you played the game and you lost. It's possible you win $1 in this game. You could win $5 in this game. Or it's possible that I guess you hit the jackpot and you win $100 in this game. So what we're going to do is we are going to take a look at this game and analyze it a little bit. Now there are probabilities here, so what this says is you have a 48% chance that you don't win when you play this game. You have a 31% chance that you win $1 when you play this game, a 19% chance that you win $5 when you play this game, and question mark. And that leads us to our first question in this problem. And that is, how do we calculate, or how do we figure out that question mark and what that number should be? So from previous problems and previous sections that we have studied, you should know how to calculate what that number should be. You should know by looking at this chart that something should be true about all of these probabilities. They should all add to 1. All probabilities must add to 1. So when you look at this question mark, you should be able to figure out what that number is. Now, if you add all of these probabilities, you get 0.98. 0.98. If I tell you it's 0.98, hopefully you're thinking and you could calculate and you know that this probability is 0.02. 0.02, that's what's left. So, question 1, can you figure out the missing value? Yes. If so, what is it? It's 0.02. All probabilities have to add to 1. All right, let's talk about expected value. To calculate expected value, we need to, remember, multiply all of the outcomes, here are the outcomes, by their probabilities. Here are their probabilities. So I've got outcome 0 times its probability is 0.48. Outcome 1 times its probability, which is 0.31. Outcome is $5. Its probability is 0.19. Outcome of $100, and its probability is 0.02. Multiply all the outcomes by the probabilities and add the results. That is the formula for expected value. And we'll need to calculate each of these values to see if we can figure out the final answer here. So 0 times any number, in this case again it is 0, plus 1 times 0.31 is 0.31, plus 5 times 0.19, that is 0.95. Plus 100 times 0.02, and that answer is 2. We need to add all of these numbers together, and when we add those together, let's see, we'll get 2, make that a 3 points, and it looks like we have 26, 3.26. That is my expected value for this casino game. Now, let's talk about question 3. What does this value mean for the casino? It means every time they run this game, I shouldn't say every time, I should say on average, when they run this game, because they're going to be running this game all day, all night, all year, they're going to be running this game a lot. On average, over a long period of time, the casino should expect to pay $3.26 per game that people play this game. On average, they should expect to pay $3.26. That's what it tells the casino. So automatically you know that in order for them to make money, they need to make sure that they charge more than $3.26. How much do they charge? That's totally up to them. They want to charge a value more than $3.26 that makes them money, but also don't want to charge too much because they want people to still play the game. Okay, question 4. What does this mean? What does this value mean for the players? For the players, it means that they should expect on average to make $3.26 per game if they play this thing all day and all night. But they need to keep in mind that they will be paying more than $3.26 to play the game. If the casino charges $5 to play the game, they're going to lose money, $1.74 in fact, each time they play. Not every time they play, but in the long run, if they play a lot, they would expect to lose about that much money per game.